Wolff-Kischner reduction. This is today's lesson. In this lesson, we are going to learn mechanism of Wolff-Kischner reduction reaction. So let's begin. Wolff-Kischner reduction. Reaction of aldehyde and ketone. This is aldehyde, ethanol, and this is ketone, propanone. Reactions of aldehyde and ketone are Wolff-Kischner reduction reactions. When aldehyde is reduced with hydrazine in strong base, ketone is reduced with hydrazine in strong base, then carbonyl group turns into methylene group. Here as well, carbonyl group turns into methylene group to form product like this: alkane, ethane. In this case, this propane. These reactions are known as Wolff-Kischner reduction reactions. After German chemist Ludwig Wolff and Russian chemist Nikolai Kischner, reduction reactions of aldehydes and ketones with hydrazine are known as Wolff-Kischner reduction reactions. That is, here carbonyl group turns into methylene group. But how? This is what we are going to learn today through mechanism. Now let us see mechanism of Wolff-Kischner reduction reaction. Wolff-Kischner reduction reaction simply change of carbonyl group to methylene group. Let us see mechanism of Wolff-Kischner reduction reaction. Carbonyl group reacts with hydrazine. Then, first of all, water gets removed at step 1 to form hydrazone. This is hydrazone. If it is ethanol, it will be ethanol hydrazone. If this is propanone, the compound will be propanone hydrazone. If this is benzaldehyde, it will be benzaldehyde hydrazone reacting with hydrazine. So, step 1 is known as formation of hydrazone. Here, water gets removed. Step 2, this entity in presence of base, this nitrogen undergoes deprotonation. This bond shifts to nitrogen-nitrogen single bond to form nitrogen-nitrogen double bond. At the same time, this bond pair of electrons turn into lone pair. As a result, this is formed. This carbon becomes negative in charge. Carbon-nitrogen double bond turns into carbon-nitrogen single bond. Here, double bond. This hydrogen combines with hydroxide ion to form water. Because this hydrogen gets free as proton. That is why this is said. This nitrogen undergoes deprotonation. Now, step 3. This entity carbon-nitrogen double bond. Here, carbon-nitrogen single bond. Carbon-nitrogen double bond. Hydrogen. System contains water. Here, this carbon undergoes protonation. From water, proton is formed. This proton combines with this carbon to form this entity. Here, hydrogen. Then, nitrogen, nitrogen double bond, this one. At step 3, this entity is formed. Step 4, this entity. Again, this nitrogen undergoes deprotonation. Bond pair of electrons turns into lone pair. Then this carbon-nitrogen bond undergoes heterolytic fission. And this carbon gets negative in charge. From here, nitrogen molecule gets free. Products from step 4 are this. This carbon becomes negative in charge. Nitrogen and water. So, negatively charged carbon species is formed. Step 5. Hydrogen, carbon is negative in charge. This carbon undergoes protonation from water. Water produces proton. This proton combines with this carbon to form methylene group, hydroxide ion, CH2 group. Methylene group is formed. That is, carbonyl group turns into methylene group. This is the mechanism of Wolff-Kischner reduction reaction. Thank you very much.